Hello, welcome back, guys. So this is the third video in the introduction to Julia series. So in the previous video, the second part, we installed Julia and added it to our environment variable. So in this tutorial, we are now ready to work with it. So I showed you that there are two ways to start Julia REPL, which is actually this Julia. It is Julia. It's called a REPL. It's what actually that is. I wanted to show you over here. It's read, evaluate, and print loop. So that is the meaning of REPL. So when I'll be talking of REPL, just know that this is the meaning of it. So I wanted to show you so that you can get it. With that, I should not be the one to tell you. At least you can see from what the Julia language we call it. So that is it. So this is a Julia REPL. So we'll be using it. So you can start it by typing Julia. That is the first way. So you open it, you open the executable direct, or you use the CMD. So when you use CMD, you have to type Julia. So you see, the good thing about Windows is that it's not case sensitive. So if I type it in caps or lower, it will still open. So that is one thing about Windows CMD. So I think you should know that. So when I type this way, it opens the Julia REPL. So the Julia REPL will allow me to type codes interactively. So for instance, if I want to say 1 plus 1, you can choose to open any of the ways I've shown you so far. 1 plus 1, and then I can show you it's 2. Again, I can say print. Now this is case sensitive. Inside Julia is case sensitive. Windows is not case sensitive, but inside Julia it's case sensitive. So I can say print hello world. Okay, hello world. So you see, now this is simply how you can write Julia code in the REPL. So if you start a REPL, then you see it has already shown you that you can start writing code. So this is not what we will cover in this video. So in this video, I plan on taking you through one thing, variables in Julia. So at least you've seen how to write to start Julia REPL and RELP. If I say REPL, I mean RELP. So REPL, is it even REPL or REPL? REPL. It's not REPL, it's REPL. REPL. I'm sorry, REPL. Julia, it's I keep forgetting that name. It's read, evaluate, print, loop. So that is it. So read, evaluate, print, loop. So that is it. So that is Julia. So in this video, the main thing I want us to cover is Julia variable. So first thing, let me ask you, what is a variable? Seconds are over. Did you think of anything? So Julia variable is just like any other programming language variable you have. So if you are new to programming, this is your first programming language you're pursuing. So don't worry, I got you covered. So a variable, if today I ask you what's your name, you'll tell me your name. What's my name? My name is Kim. So name is a variable which holds my value, which holds the value which is my name. So if I ask if I'm asked what's my name, I'll say Kim. So variable is a name assigned to a value. So yeah, variable is a name assigned to a value. So if I ask what's your name, you will tell me your name because name is a variable. So for instance, name is equals to Kim. So you see, the variable here is name and the value is Kim. So you can say again x is equals to 1. So you see, the variable here is x and the value is 1. You see, x again can be 5, it doesn't have to be 1. So you see, this is just a value. It's a name you assign to a value. It's not a value by itself. Now if you wanted to access the value, you type x and it will print for you 5, because you see, it's like I'm asking you what's your name. You see, what's your name? And then it says, my name is Kim. So that is it. That is basically what a variable is. It's a name associated to a value. So that is variable. So in Julia we have several variables. We have strings, we have numerical like floats, and integers. So integer is a whole number, while float is a decimal number like this 5.6. No, I'm sorry. I just created something. I should 5.4 point, let's say 5. This is a float. 4 is, so I think it's always type of or something. I'm sorry guys if it's not 0.5. Yeah, you see, it's float. If you type of, it will show you. Let's type of, let's say 1. See, then it's an integer by default. Again, this is another thing. Julia will show you your system by default. If you're using a 64-bit architecture, then the default integers and float will be used according to integer. If you are using a 32-bit architecture, then it will be float 32 or integer 32. So that is what Julia does. It uses your system architecture to show the default number size. So my case is 64-bit, that's why it's showing me float 64 and integer 64. If you have 32-bit, don't worry, that is just still fine. I mean, 1 plus 1 will remain the same thing even if we integer 32. So that is it, guys. So we have floats, we have numbers. I've already shown you numbers, floats, and integers. So what if I add 1.2 plus 1? You see, but and then I say type of, let's say 1.2 plus 1. You see, Julia allows you to add integers and floats without no stress. So that is the good thing. You don't have to have the same type so that you can have something like that. So it works, and the type of value will be shown. So that is a good thing. So we have, however, we still have this. I showed you something over here. So let's say type of name, type of sorry guys, I really do that. You see, this is a string. So string is a group of values like this. So this makes it a string because it's KIM. This one is a character, this is a character, this is a character. When you group several characters together, it becomes string. So like, I'm sorry guys if it was small, let me make it big. I'm sorry, I'm really sorry. Type of name, you see it's string. Type of that is a float. I'm really sorry. So we have another thing, let's say character. So let's say type of, you see, this is a character. A character is a single value. Like it can also be like a number like that, still a character. It has to be one and can be in single quotes. So you see, this works. It can be, it should be in single quotes. It should be in single quotes for it to be a character. As soon as you use double quotes, it becomes a string. And let me show you another thing. You cannot do something like this. You see, it will return multiple characters inside a character. Character has to be one. I mean the character, so it has to be one. What do you call one character? I mean, that is the only thing that can really describe it. So that is basically the difference between characters and strings. Characters we use single quotes, strings we use double quotes. So as soon as you use, in most cases I don't think you'll ever need to use characters in programming, as mostly in Julia. Most of the time you'll be using strings. So strings can hold anything. In that case we used name, which was key. Actually it was showing the type of, you see here it was showing the type for key, for Kim, not name by default, because name was variable pointing to king. So you see, that is it. So now we can say no, I'm about to show you something different. So variables are case sensitive. You have already seen that. So variable is case sensitive. So you can say my name equals to king. That is my name. My name is king. I'm going to say, I think if I keep doing this, then I better close this and start afresh. My name is king. Yeah, better this. My name is king. So this, if I say my name, I get an error because name is not defined. So variables are case sensitive. So, but mostly, if you from language like JavaScript or Java, then I guess this is the what is called convention, the preferred convention over there. But in Julia, variables name, you prefer to use something like this. My name. Even though if you want to complain when you're doing this really bad, most of the programmers will like you to do this, and it's a convention. We have different ways of doing things. Over time, I'll start showing you things called functions, modules, and types. So as of now, we are just covering variables. So know that naming variables, when you have more than two words you want to combine to make a variable, then you will use an underscore to separate them. Even though this will work, but this is not the convention of here. So, and it's case sensitive, as you see. My name failed there, but you will do my name. You see, we get the real value, not that this is not existing. So just always remember, the name you give has to remain. So Julia again has other special, what do I call them? Unicode math symbols like alpha, delta, such things. So you see, if I do something like this and then type delta and delta, you see, then the delta symbol is drawn, and I can use the delta symbol as a variable name. You see, and then if I do now delta slash delta, you see, and hit enter, the value for the delta is done. So that is a really good thing about Julia. As of now, this is really nice when we are working with REPL, but over time we'll start writing codes in editors like Atom. So when using Atom, I'll show you how we can get this working over there again. So as of now, we can do, if you also type alpha, let's say alpha, and enter, you see alpha is drawn for us. And then we have again inbuilt variables in most of languages, like pi. Let's see pi. You see, if I type pi and hit enter, then the value for pi is predefined. 3.141592. You know what is with pi? You see, we still get the value. So this one and this is the same thing, pi and pi. So what if we try doing this? You see, we get, you cannot assign variable to math constant because it's a constant. You cannot start using this again. You cannot assign value to this because it's a constant. So over time again, I'll start explaining to you what it means to have a constant and a variable. Constant is, in short, is a variable whose value you cannot change. That is it. So guys, the video has been long. I've shown you a lot of things, so please don't forget to subscribe if you've not subscribed yet, and please just a like if you think this was cool. So in the next video we'll start talking about, no, we'll check out. So please don't forget to subscribe, and if you think you like it, leave a comment if there's something you like or didn't understand. So goodbye.